Okay, hi everyone. Welcome to this robotics session at the CAS Virtual Showcase. I believe we were broadcasting early, so you've had a nice little chat between myself and Lee as we started off. And I hope you can see that we're going to have a wonderful creative look at robotics in the classroom. I'm just going to give you a quick bio of Lee. So Lee's the digital technology lead at Northeast Futures UTC in Newcastle. And he's going to be sharing with you about robotics in the classroom. I just want to share with you some other stuff in terms of what's coming up on the CAS Virtual Showcase. So just to let you know, later today as well, before Lee takes it away and introduces himself in more detail, we've got the inclusive computing classroom at 2 o'clock today, and we've also got planning for progression using learning graphs later on at 3 o'clock. So that's what's coming up. I will hand over to Lee, who will take us through the session. Thank you, Lee.
Thank you very much. So, hello everyone. As pointed out, my name is Lee Willis. I'm the digital tech lead here at Northeast Futures UTC. For those of you who don't know the purpose of our UTC here in Newcastle, we were kind of developed to fill a hole in the digital technology economy here in the Northeast. So all of our students will come and do either a healthcare specialist or a digital technology specialism. And if they pick digital technology, they'll do the GCSE and A-level computing. And then we'll also provide them with a plethora of other resources regarding computing. One of these happens to be developing robotics, which we will start talking about very soon. Some of the other things I'll do here will be virtual reality development, will be a vocational course, will be work experience, will be AR, which we're starting next year. So it's quite a wide range of stuff we do here. In terms of robotics, this is something I've been teaching for about 5 years. I've been fortunate to teach from year 1 all the way through to year 13. And I've embedded robotics as much as I can across that. So hopefully I'm going to give you a pretty wide range of resources and help today that can work with this. So I've just put my PowerPoint on the screen. Hopefully you can all see that. And what we're going to be looking at then today is how I use robotics in the classroom, how I use them at different levels, how we take them into the outside world, and especially why students really enjoy getting involved in robotics. So these are the 3 main reasons we really like using robotics here. Now, we all know we're not in teaching just to make students pass an exam. We want students to leave the UTC environment here being creative, being able to collaborate, and being problem solvers. And robotics gives them a really, really great way of doing it. Now, if computing just on a computer all the time, it would end up being a very, very dry subject. And there's a saying that computing relies on a computer as much as astrology relies on a telescope. It's so much bigger than that. And robotics is a great way of making that saying be true. In terms of creativity, the open-ended nature of robotics allows for a huge amount of creativity. Some of these I'm going to be talking about in a while. The collaboration aspect means, our students will have to work together to solve an open-ended problem, which we'll discuss. And the problem-solving aspect of it, due to working as a team, due to working on creative tasks, allows open-ended challenges where there's multiple solutions for a given problem. And the students are going to learn the importance of taking risks, of taking chances to try and solve these problems. It moves away from there being one set answer to a question rather than a plethora of different ways of looking at a solution. So Key Stage 1. This was my Key Stage 1 class in my previous school out in the United Arab Emirates. We use a technology here called Beebots. Now, Beebots are these, you can see them on the floor, are these very small and very cheap programmable robots. They are completely PC independent, so they don't need any setup via any hardware. They are incredibly cheap. They cost around £8 each. I think you can get them for a bit cheaper than that if you buy them in bulk. They're very easy to use. There's no interface apart from up, down, left, right, start and stop arrows. There's excellent cross-curricular links too. You can see here that we're using a times table mat. And what we're doing there is I'm putting numbers on the board with an operator, so plus, minus. The students then figuring out the sum of that, and then they're progressing their Beebots around the mat to land on the answer. Then if they're falling short or they're going too far, they're taking it back, They're discussing where they went wrong, and they're having another go at the work there again. It was very, very engaging for the students. And finally, language dependent. Now, this one was a little bit focused more on the UAE, where I had 98 different nationalities in the school at any one time, and especially going down to primary level, the language varied quite dramatically. However, these are language dependent. So if a student does have EAL in your classroom, or their language skills just aren't as advanced as they could be, these break down that barrier. So they allow huge access to the work as well. It can be easily differentiated by using harder sums, or also by putting roadblocks in the way. So they have to navigate further problems by discussing them, which makes them a lot more challenging for the students that need that extra bit of stretch and challenge. So these Beebots are a great way of embedding robotics, cross-curricular links, stretch and challenge at a Key Stage 1 level. Next, we as Key Stage 2. So these are Sphero minis. And again, it takes the principles of the Beebots and just makes it that little bit trickier. What it does is this does require an app that's available on iOS or Android, and using a block face interface, similar to Scratch, but a little bit cleaner to use. Students will develop code that will move the ball around. Now, at the moment, I'm actually using one of these at home with my 2-year-old. She's not dragging and dropping code, nowhere near it yet, but she's understanding cause and effect, where if she moves her finger on my phone, it will move the Sphero ball around. And at the moment, she's using it to chase the cat, which I need to maybe stop doing. But this allows students at that Key Stage 2 level to start dragging in blocks, and it starts developing their coding knowledge as well by bringing in loops. For loops, while loops are all in there too. It allows them to change the color of the glowing lights within the Sphero, and it just allows them to develop that slightly more complicated relationship with coding. These cost around £40 each. They are a bit more expensive, and it's a little bit more tricky that they are dependent on an app as well. Key Stage 3, we started getting more advanced into our coding now using these Cosmo robots. Now, these Cosmo robots also, you can see there that our students are using them with the apps on the bank of iPads. However, they interact with these certain cubes that you can see just down here. What this requires them to do is, by putting in much more detailed blocks of code to make the robots manipulate them as they want, it allows them to move them around. You can see on the maps where the robots will recognize where the squares are they need to put down. And you can see here from all these photos too, it's really encouraging a large amount of teamwork. It wasn't just because of the cost or the outlay of the storage or anything else here. These robots do encourage problem solving, which leads on to having great opportunities for collaboration and having students work together to solve these problems. And at the moment here in the UTC, we are using something called VEX Robotics. Now, the VEX Robotics kits we use here, which I'll introduce you to shortly, is something called the competition pack. What we do, and I'm going to be happy to share schemes of work with anybody who'd like them too, is we teach students about the individual components that they're using. So you can see here that we teach them about batteries and battery technology. We're teaching them about motors. We're teaching them about drive shafts, about how wheel technology is used. We're teaching them about switches. We're teaching them about crankshafts. We're teaching them about grips and claws, and we're teaching about the main GUI too. So what we will do is we will discuss this with the students. We'll be learning about this as we go along. And then to start with, what they will do is they will follow a set project, and they will build a robot based on that project too. What will then, after maybe 4 or 5 weeks, is we'll demolish all the robots after they've built them, programmed them. So they will be using the remote controls to program the GUIs to send power to the wheels based on certain commands using cause and effect. And then what we'll do is give them a scenario. And the scenario might be, we will make a racetrack in the school hall. So we will lay out obstacles, we'll lay out track, and we'll make it like a timed circuit they need to do. We might make it a bit more problem solving. We have access to 3D printers here, so we will develop some objects on the 3D printer, and then we'll need the robots to manipulate those objects. The picture on the right-hand side shows the claw we've been using, and they'll need to, say, lift some some cubes they've made into a basket. And then again, we'll embed competition into that to see who can get the top score, or how we want to do it. We'll do flash challenges, where what I'll do is I'll take away where they need to put the squares they make, and I'll just make a small box, and I'm like, right, you need to change your robot now within 2 lessons to actually push the boxes in. Chris, the VEX Robotics kits, they vary in cost. They can start quite cheap, around, I think it's about £50, but then, the more robots you buy, the more wheels, the more kits and everything else, they can go to around the £1,000 mark. I'll show you a quick picture of what we've got here too, and you can get an idea of roughly how much they cost. Steph, students per robot, at the moment with the kit we've got, we're sharing about 4 to 5 students per robot. And then in the robotics club themselves, that's just down to 2 per robot. I think that's about a good mix, because what we do is, I found when I was first teaching this, that some students were just dialing it in. They were just, oh, well, these students really engaging with it, and some other students were kind of on the wayside. So what we then did was started assigning roles to it. So there's one student who pops to mind who, for lack of a better word, is a little bit challenging in some other subjects, but he just loves fixing things. And he's really good at actually going around other groups and jumping in and going, right, what's wrong with this? So at the beginning, it's not a really fluid start to the scheme of work, but students will find certain aspects. Some of them will get engaged in the 3D printing, some of them will get engaged in the problem solving, some of them, like me, just want to meticulously follow the instructions like it's an IKEA set of cabinets. So again, any more than about 5 to a group, I think some students do feel they can fly under the radar a bit. So we can, after we followed a set amount of instructions, we can then give them scenarios, and then they develop the robots to solve the problems, which has been really, really good fun. It's been really engaging to see. So some of the scheme of work. Now, I'll be really honest, this has been a huge moving target all year. I've been quite lucky here at the UTC, where we have had this flexibility because we have so much computing provision, where I can make mistakes in the scheme of work and understand how best students engage with this. But we found that the students learning about the individual pieces of the robotics has been really beneficial. To start with, following a path, treating it like IKEA furniture. This is how we work on a robot, guys. This is how the controller will sync with the GPU, and they get those key skills. Then dismantling the robot, which doesn't go down well sometimes, especially since I've done such hard work doing it, and I'm like, yep, break it down, guys. Then setting a goal, allowing them to build their own robots, set a challenge time, and then we just do that again if the time allows within the scheme of work. That's been really, really engaging. A lot of trial and error with that, but it's been something they found to be really useful. So field trips, well, as well as field trips, real world links. The amount of time that we've actually moved away from the nuts and bolts of robotics and discussed the ethics of robotics has been really interesting. We did actually lose about 30 minutes in a lesson once because a student wanted to discuss how much his car was becoming a robot. It was really interesting. We looked at how Teslas are, really putting in all this self-driving and how ethically correct that is, where the legal ramifications of that are. We then also looked as well in cars as well about battery technology, and that leads us on to Nissan. The Nissan factory in Sunderland is only about a 30-minute drive from where we are here in Newcastle, and they've been fantastic, not only allowing us to watch the, quite frankly, awesome production plant in progress, but they've also been really good at allowing us to, we brought down our robots and then we mapped the robots. Oh, well, look, there's their motors, there's their, their grips, there's their wiring, and compared it to our robots too, which the students just really engaged with. It really kind of brought what they were learning into the real world. And it was incredibly interesting, if incredibly noisy day out, which was great. And then some national competitions. We've entered these VEX Robotics competitions, and I think if you say to students two things, right, this is a national competition, the engagement goes absolutely through the roof. And also, if you say, I think there's a Nintendo Switch in this for you, you really find your club. Carol, Nissan did charge us for the trip. I believe it was £225, and we were limited to 18 students due to health and safety. Now that £225, Carol, I can't remember if that included the bus or not. I'll speak to our bursar and try and get back to you with that if you'd like to leave your details. And it was we were on the factory floor for about 2 hours, and then there was maybe half an hour each side, health and safety, and then comparing our robots, and then getting from Newcastle there and back. So I think we're at the school about 5 hours. The students really enjoyed it. They just found it really engaging, and it's such a huge environment. I hadn't been anywhere else like it, and the guide we had was incredible. We were all kitted out with headsets and mics, and he'd actually worked on the production line since it opened. He'd recently retired, and he knew absolutely everything about every robot, the process, how they work collaboratively, long distance with the Nissan factory in Japan, how they implement all of these new ideas. And the students just found it really, really engaging. We found Nissan to be a fantastic business link to have. So I would definitely recommend if the budget and the time's there. These VEX robotic competitions are fab. They work similar to our schemes of work, where they will give us a scenario, and then we will build a robot to compete against it. Now, we've been doing this as a club, actually, because we offer a provision every Friday afternoon in the UTC. So we will reproduce the robot I'm going to show you guys in a second, called Fear the Wheels, which I had no say in. And this was then built to do a competition in Washington. And then there's a national competition, which has obviously been cancelled due to current circumstances, down in London, which we thought we would have had a really good chance winning. The students who did this, again, were just really engaged in robotics themselves, in the problem-solving aspects of it. And again, it was a really, really good club to run. I really enjoyed doing it, and I'm just really hoping students who are in year 11 who did it come here for sixth form, and they can have another go at giving it a competition next year. We'd really like to maybe start up a much more local competition with other UTCs or with other schools. It would be a really great thing to do. What we also do here at the UTC is something called Digital Schoolhouse, where we get primary schools to come in. And if we can maybe bring this down to a primary level as well, it would just be something we'd all really enjoy to do. So just to go over some of the kit then. So the Sphero on the left-hand side, that's my Sphero. It's just a really engaging device. I would really recommend, if you are in primary or especially Key Stage 3, just maybe buying one for yourself, and then getting to grips with it, and then looking at how you can embed that in a scheme of work. They charge a micro USB. They're incredibly versatile. It has survived my 2-year-old throwing it down the stairs repeatedly. And I just found it a great little toy to use. In terms of a question I think Steph raised earlier, if I was to get those for a Key Stage 3 class, you'd probably need about maybe 6 per class, maybe 7. And then again, you would set up a track, with blocks in the way, and then have students, troubleshoot the track. And you'd need to delegate, who's going to program it, who's going to problem shoot it, who's going to, navigate the track, a few things like that. So the cost does jump up a bit. You'd also need like a bank of iPads or some other method of having them program it. You could have students run it from your phone, but then that depends on your own school's individual policy for how you'd want that to be managed. The Beebots as well. Again, we were using them primarily in Key Stage 1. I have helped out schools who have had absolutely zero computing in their feeder primary schools, who have kind of come to me in a previous role in Newcastle and said, right, we need to start from the basics with programming. And then we've embedded those at year 7 too. Again, about students no more than 5 to it, similar with the Spheros, but year 7s will pick up the whole programming concepts of this incredibly quickly. So again, definitely no more than half a term with this. Moving forward, we have got 6 of these on the horizon called Velodromes. When I worked out in Dubai, I was lucky enough I bought one of these myself, and I convinced the management there to buy a few more by flying that into an SLT meeting, just to kind of prove my point about how great they were. Again, like the Sphero drones, they work on an app. It's all drag and drop and block coding. There's no legal requirements you need to manage with these. They fall under the 250 grams of needing a license or needing them registered. The camera at the front is only a 720p camera, so there's very, very few security issues there. And because you'll be managing the devices they're on, that will help. And then also in the settings, you can just turn that camera off right away. Again, it really, really helps year 9s, so year 7 to 9, more year 9s, find them incredibly engaging. They are more tricky to use because they need a little bit more help with navigating them on a 3D plane. In terms of health and safety, they come with guards around the propellers, and again, they are quite cheap. They are actually DJI made, the ones that make a lot of the commercial drones. So the parts are very easy to replace, and they're very easy to help with too. I believe there's a question there from McDermott. The NCC are producing robotics kits. I haven't heard that. No, that would be something really interesting. I'd be really interested in maybe having a look at that and helping out. That drone make is called Tello. However, it's a DJI designed drone that uses Intel chips. So don't think it's like a cheap, knockoff drone or anything like that. It's very, very well supported, both in terms of the hardware and the software. So I'd really, really recommend that. Let me just jump back to where we are. So we've got a few of these arriving next year. What we're going to do is we have an outdoor pitch here with a net on the ceiling. So we're going to be using that just to get them started. I'm really looking forward to this. I'm going to find it very engaging. What we are also doing as well is, let me just jump back one, sorry, is we're getting a few more people involved just to, so the Tello drones, Anita, they cost about £89 each. However, there's a few companies supplying them where the more you buy, the lower they get. So what else we're doing as well is we're getting more and more people in to talk about robotics. We have a gentleman from Nissan coming in next year to talk about some of the more self-driving aspects, the more autonomous aspects of their cars that they're putting in place. We've got them coming in too to talk about the batteries, which obviously all robotics have, and they produce a Nissan Leaf there too. And then we're hoping to get the police in to actually talk about some of the robotics they use as well, which will just be really engaging to have the police come in and look at the robots they have too. Student voice, I'm really sorry I couldn't actually get these filmed, guys. Obviously, we've not had a student here since March. But this is some of the feedback I asked them for. They enjoy that they're in charge. And I asked them for a bit more detail on that. And they were like, it's greatly to have you talk at the front of the room sometimes, but they really enjoy just coming in and going, right, okay, that's not turning left. Why is that not turning left? And then they'll discuss that and figure it out as a group. They say it's great to listen and talk with the class. Again, they've just really enjoyed not hearing my voice, I suppose. They've been really getting on with talking to each other and problem solving with each other. Nice to follow your own path. It's gave them this huge ownership of their learning, that they are doing their own thing to get to the outcome as well. Being in competition, again, they just love getting one up on each other as well, and seeing problems get solved. They really, really enjoyed having evidence that they've solved a problem. It really helps with their engagement, with their self-esteem, with their mental well-being. that there is physical evidence that they have overcome a problem right in front of them. I mentioned this to the GCSE group, and I said, but you guys all have code that won't work, and you'll debug it, and you'll solve a problem that way. And they just said, no, Lee, it's so much more different when it's something we've built that we fix with our hands. And I understand that, and that's been just something they've come back to me time and time again about. Right, so we'll just jump into a Q&A then. But before we do that, if it's okay, I just wanted to roughly show you the robot that we developed for our competition, Fear the Wheels. So if you just have a look, I'll just take this off, bear with me. So this is one of the robots that they produced. It's called Fear the Wheels, as you can see. It involves them with two motors at the back, here and here, that are connected to the GPU, which is then connected to a sensor, bear with me, sorry, down here, that links to the remote control. Now, what they will then do is they will program the remote drive and run. So you can see that they will use Fear the Wheels. I'm going to put that on the floor because knowing my luck, I will end up breaking this quite substantially. So what they will do is they will use the controller to program the robot and then using some of the objects we've built. So here, if you can see, we have just 3D objects, and then they can pick that up and then lift it up. And then what we'll be using is they will use various problem-solving methods to achieve the goal. As I mentioned, we've built smaller robots that they'll be used for racing, which the head teacher loves us doing on the floor. They'll be using these bigger robots to manipulate objects and move them around. Sometimes we'll have them controlled by the students, just using the controllers on the kits. And sometimes they will program the robots through that task autonomously. One task we did do was having a program navigate a maze for the first 30 seconds, and then the controller would activate, and then they could race it around the maze and set the time for everybody else. I think that covers most things I wanted to talk about today in that case then. Overall, the students find it incredibly engaging. There is an outlay to it financially, which I understand not every school can really match, but it's just been something that students have looked forward to every lesson. And it's something that we're growing here at the UTC with the Velodromes, with national competitions, by going out to Nissan, by bringing companies in. And to go back to my original point, it allows creativity, it allows problem solving, and it allows collaboration. And I think those three skills are three skills that me as a teacher, and I'd like to think every other teacher here, is really committed to embedding in all of our young people. Everyone, thank you for listening to me drone on regarding drones as well at some point. Are there any questions at all?
I was just saying there's just a couple of questions just come in. I wondered if you're okay to just run through some of these. Is that okay? So Steph has just sort of said that she's entered a competition recently went to RAF Cosford, and she's sort of just basically saying, is she able to contact you a little bit more about robotics? But then she also asks you, do you teach robotics for GCSE computer science? So a couple of things there altogether.
I would love to hear from you. Please pass on my email address. Regarding teaching it for computer science, we won't be doing it with next year's year 11s just because we're kind of against the clock with however September looks. But we are moving from AQA to the OCR, so I'm looking at embedding a small amount into it. The only issue is the kits where we have, if I use them with the GCSE and the vocational UTC side of the school, I'll just run out of stuff quite quickly. But we will be bringing some of the robotics into the GCSE.
Great, thanks. See, they're firing in at the minute, so I'm just going to give you some more. I think you've just captivated everyone with that. So there's loads of questions coming in. One of them is we've got here is can we have access to your schemes of work for what you use for robotics? So is there anything you can share
no
or
problem.
help with guidance?
No problem. I'm just actually changing them at the moment, just for internal reasons. They're not going to be finished until next Friday, but I'm more than happy to send on the 12-week scheme of work we use on the carousel for the year 10s if you can wait till next Friday.
Great, and there's a question from Chris, which says, have you used Lego robotics equipment or competitions, and if not, why?
No, I'm desperate to, though. I really don't know why, because the more I read into them, the more I'm thinking, why aren't I doing this? It is my birthday next month, so I might treat myself to a Lego Mindstorm kit and just be using it. I've not heard anything bad about them, to be honest, so I'm not sure why I haven't really engaged with them, but I think I might treat myself to one just for my own fun and look at it that way.
Brilliant, thank you, Lee. Oh, there's a question about you mentioned about VR creation. How do you do this? And that's from Chris.
Chris, at the moment we've got 3 Oculus headsets that arrived at the beginning of last year, and I'll be honest with you, we are starting with them next year. We're developing something in Unity where the students will just create some tutorials for them, and then I believe we're then going to move on from that to them creating small walkthroughs for the history department. This is very much the scheme of work in development. We're finding it quite a difficult topic to engage our learners with, but it's Oculus Quest headsets. I think I've got one somewhere. No, they've been locked up because no one's been in school for a while. Yeah, they're Oculus Quest headsets. It's using Unity VR. And again, but I'm more than happy to stay in touch with you and just share our resources as we're developing them. The main issue is we've just found it quite difficult to start with at the moment.
Great, brilliant, thank you, Lee. I think you've run through most of those, and that's absolutely great. Can I just thank you again for giving up the time for the CAS Virtual Showcase. Lots of thanks coming in as well, and that was brilliant. And your, I was not expecting your actual your demonstration of the robot during the session, so that was absolutely brilliant. And the way that you were just taking questions as you were presenting just meant it was great. It was absolutely brilliant. Multitasking through that, amazing. So thank you, Lee. Thanks, everyone. And like I say, do check the virtual showcase listings. There's lots more coming up to get involved with, and have a wonderful day. And thank you again, Lee.
No problem. Thank you for having me.